Yes, my name is Jeff Kim, and I, along with Darren Olsen, we're both professors at the McWhorter School of Building Science at Auburn University in the United States. So to give you some context of what we're doing here, this is an action study, a study conducted with students, and it was a dual action study, so I'll get into those details here now. So just to briefly touch on the literature that supports this research. Most of it's not uncommon knowledge, but the industry is sensitive to errors, mistakes, and omissions. And the process of construction is a very complex process and continuing to get more complex. So it's a pretty intense orchestration of very time-sensitive events. But as most will know, quality management within construction is a significant challenge with less and less investment from organizations, mainly for the support and the valuation of profit over certain other aspects of the project. Also, a secondary problem is that there are individuals that we need in the industry, individuals that must be experienced and practiced within the industry. Those skilled individuals are retiring out of the industry, leaving the industry in greater numbers. This isn't just true for the United States, it's true worldwide. So this forms the basis for the literature that's out there that supports the need for our action research. And in this research, we took two separate objectives. The first was to equip students with foundational skills that enhance their overall industry practice, enhance the overall industry practice of improving quality. So we're focusing firstly on quality with our first research objective. And then the second is to provide modernized approaches toward educating our students with the potential to move that education over to industry practitioners down the line. So we had two objectives, and to get into the study, essentially what we've tried to do is we're trying to use augmented reality to support a solution to both of those research questions that we defined. So in our setup, the first stage was basically to take a model that you see there on the left-hand side. We created a very simplified model of an actual condition, which you see on the right-hand side. This is a site experimentation location where students can go learn, practice, and mimic basic construction technology or basic construction processes. There were four different types of devices that we chose to use. So starting from the left, that's the iPhone, and then the iPad. And then moving a little further to the right, you have the HoloLens XR10 Trimble device. And the far right is the Trimble SiteVision. These are all augmented reality devices. The two on the left, the iPad and the iPhone, we're going to constitute those as very passive AR devices. They're not anything that's difficult to get to, but they're not as immersive. The two on the right are a little bit more immersive. The headset that you put on your head engages you in a different way, as well as the handheld Trimble SiteVision. So they both engage a little bit differently. And we're going to call the two on the left passive AR versus the two on the right that are more intensive or immersive AR. So again, in this workspace, what we did is we created an area or a region that you see on the left-hand side that the students could work in. And what they're trying to do is, as you can see on the right-hand side, they're trying to locate plumbing stacked piping that would eventually go into a concrete slab. So something that has to happen before you do your concrete placement for a concrete slab. And of course, if you misplace these items or you misplace any of these pipe or plumbing pipes, it's pretty costly and pretty time consuming to fix that later on in the field. So the idea here is to educate students with a device, the AR device, on how to actually properly place those, and then to just measure their accuracy later on. So again, what you'll see on the left-hand side is the model that the students would see on their respective AR devices. It looked a little bit different on each device, but generally what they're seeing is they're seeing this location. They can zoom into specific spots within the model. And then what they're trying to do is take the item that you see there on the right, which we call the placement prism. It looks like a plumbing stack or a plumbing pipe. And then on top of that, it has a surveying prism that will later calculate their error accuracy with. And what they're trying to do is they're trying to move those around and visually get those lined up with what they're seeing on their respective AR devices. Then once they're finished, we take measurements of their actual placement. We used a total station to get the precise placement. There was a total station used at the very beginning as the control for each one of those. So then we're going to be able to compare where the student placed it versus where the initial setup started. So very quickly, just to get into some of the information, we took the positional information, kind of categorized it and grouped it. So we summarized the information between the non-immersive devices versus the more immersive devices. So the non-immersive devices are the dots that you see there in green. Those are going to be the iPads and the iPhones. And again, these are much more readily available, easy to get to, and easy to use. The immersive are just the opposite. They're the ones that are headset devices and also the handheld device. And you'll notice that the interspersing of the red dots versus the green dots, they're a little more tightly spaced onto the bullseye. The bullseye actually represents those pipes. The very center point represents the very center point of those pipes as well. So if you placed it exactly over the center, then you got it perfectly placed accurately. No one actually did that, but that wasn't necessarily the expectation out of this study. We're just trying to measure accuracy and also educational value here. So in terms of numbers, this is how it worked out. There were 3 pipes, A, B, and C, that you see there on the far left. And then we have the 3 types of device. We have 4 types of devices represented here. The larger the average error, the farther away they were from that device, from the center of that device. So you can see that the HoloLens, the SiteVision, generally are going to be tighter, closer to that versus the iPad and the iPhone. This was expected. It's nothing surprising. But also we use standard deviations to find out how often they got close to that center point. And also those standard deviations are going to be a little bit lower for the HoloLens and the SiteVision as well. So the more immersive devices tend to be a little bit more accurate here. We also did, since this was an educational exercise, we did use the NASA TLX survey to measure performance on 6 different subscales. Sometimes this is a good measure, sometimes it's not, but it's a way to get some data out of the process. If you look here, generally what you're looking for are larger negative numbers in terms of effort, with the exception of performance, which is in the center there. You'd like that to be a fairly high positive number. And these are the results that we're seeing in this study. So what that tells us for the objective number 1 is that the mental, physical, temporal effort, overall effort, which indicated less demand, indicates an improvement toward cognitive skills for the students with low frustration. And of course, the higher perceived performance also indicated the same as well. Lastly, we also asked the students on a Likert scale, did this help? Did it distract? Was it easy to use? And would you recommend it in the future? And again, very similarly, we had categorically results that were higher on, these devices did help them. They did not distract them, with the exception of maybe some novelty where we do have 11% indicating that it did distract them to some extent. So there might have been some novelty here that did impede some learning here. So that supports research objective number 2, which is creating a device that could be used potentially for industry to support training effort here. So in our conclusions here, there were some limitations in the study, as there always are. We did have a fairly small sample size. There was only 8 students with 32 points that we measured. The long-term benefits were definitely not examined here, but they should be considered because those are always going to indicate whether or not the objective was met. In the future, we will consider actually broadening the application of AR in the classroom, providing this exercise within the classroom to look at that long-term impact and also considering this in a comparative study between using AR versus not using AR for the same activities. So that completes the conclusion of what we did. And thank you for your time listening and offer any objective questions if you've got them. Thank you.